Hey everyone, so today we are answering this question. We're going to talk about how to calculate a rate law from a set of data, how to calculate a rate constant using correct units, which is very important. And this is with AP Chemistry in the kinetics unit. If you guys enjoy the video, please subscribe or like it. It would mean so much. So let's start with letter A. So first of all, let's just examine the problem. So they have our balanced equation up here, which is very important when we're going about our problems. And it's a reaction between mercuric chloride and oxalate ion in hot aqueous solutions. It says the reactant rate may be determined by measuring the initial rate of formation of chloride ion at constant temperature. So that's what we have over here, initial rate of formation of Cl-. And in different experiments, they tested different concentrations of mercuric chloride and oxalate, as shown in the table. So the first question, what it's asking us to do is find the rate law for the reaction above. So hopefully you know that a rate law, I'm just going to write out the formula over here. Its rate is equal to the K, which is the rate constant that they ask about in the second problem, times the concentration of the reactant. So our first reactant is HgCl2, and that's going to be raised to M, and I'll talk about what M is in 1 second, times the concentration of the second reactant, C2O4, 2 minus, and that's going to be raised to the nth power. If you had a third one, it would be raised to the L power, but we only have 2 reactants in this case, so we just need to focus on M and N. If you don't understand how to get to this rate equation in the first place, comment below and I can make another video on how to get that. So M and N, what are they? They are actually the order, M and N. It's called the order. And that's what we're going to be calculating. When you find the rate law, you need to know the values of M and N. You can't just keep it as M and N and say this is the rate law. No, we need to find the actual values. So let's go about doing that right now. So the first thing that we need to do is sort of look at the data. I'm just going to go for HgCl2 first. So I'm looking for M right now. Because it's first, but you could start with C2O4 2 minus if you wanted to, but I'm just going to start with HgCl2. Let's just make it nice and easy. So the first thing that you want to do, what you're actually going to do is you're going to end up doing two experiments divided by the other. So one experiment divided by the other. And what I mean by that is I'm going to do a concentration of HgCl2 divided by a concentration of another one. So if I want to get HgCl2 by itself, that means I'm going to have to find values that makes the C2O4 2 minus cancel out. And to find that, that means I need to have equal concentrations for C2O4. And I can see that the only 2 experiments that have equal concentrations of the oxalate ion, which is C2O4 2 minus, are experiments 2 and 3. Because it's 0.404 and 0.404 molar. Those 2 are equal, so when I do 0.404 divided by 0.404, I'm just going to get 1, and that'll be perfect. So now I need to look at which one is bigger than the other. So 0.836 is obviously bigger than 0.418, so I'm going to want to get a whole number, not a fraction. If I did experiment 3 divided by experiment 2, then I'm going to get 1/2. I don't want to do that. I want to get 2 just to make matters way easier. So I'm going to do experiment 2 divided by experiment 3. Perfect. So when I do that, I'm going to start by doing the rate because it's first asking for R. So the R, and again, we're doing experiment 2 divided by experiment 3, just to understand. So we can see that the R of experiment 2 is 2.08 times 10 to the negative 4. We're going to keep our units here, moles per liter times min. The units are very important. On the denominator, we're going to have experiment 3. So we're going to have 1.06 times 10 to the negative 4 moles per liter times min. So hopefully you guys understand why we chose experiment 2 and 3. It's to cancel out the C2O4, and we did 2 divided by 3 because we want a whole number. So from there, we're going to have our K value, but we're also going to have the K value on the bottom. Hint, hint, it's going to cancel out. The HgCl2 concentration for experiment 2 is 0.0836 moles per liter. That's the same thing as M, which is just molarity. So you might see it like that as well. That's going to be raised to the M power, because that's what we're trying to find here. And then on the bottom, we have 0.0418 moles per liter. That's going to be raised to the M power. And we're going to add the C2O4 next. That's the next part of our rate equation. But you'll see that it's just going to cancel out. And that's exactly what we wanted to happen, because we're only focusing on the oxalate ion concentration right now. So we see that these two are just going to cancel out. Likewise, these two are going to cancel out, but we're left with this. So let's actually do this operation. If you plug, how about you guys plug this divided by this into the calculator and see what you get? So once you do that, you'll see that you get 2.08 times 10 to the negative 4 divided by 1.06 times 10 to the negative 4 is actually 2. So let's keep our units here. And then likewise, when we do 0.0836 divided by 0.0418, we're also going to get 2. So that's pretty exciting. And actually, does anyone see a mistake that I made? You're dividing one by another. So these units are just going to cancel out. We don't have that unit. Same thing with this. Moles per liter, you're doing moles per liter divided by moles per liter. The units are going to cancel out as well. And we just have 2. So we have 2 equals 2 to the m power. That m power is going to stay. So 2 equals 2 to the m power. What does that mean m has to be? M has to be 1, therefore. 2 to the first power is equal to 2, so therefore m has to be 1. So there we go. We found m. So I'm going to start writing our final answer over here to letter A. R equals K times concentration of HgCl2. M will be equal to 1. I guess I can just put it there, but really you don't need to put the 1 there, but just so that we understand, that's what I'm going to do. So now I'm actually going to erase all of this because I want to do the next part of the problem. I wish there was a faster way to do this, but anyway, the next step is we're going to try and find n. Once we do that, then we will be done with part A. And then part B is actually really simple once we have this rate equation down. So now we're going to be trying to find what n is equal to. And with that, I'm going to go a little bit faster because hopefully we understand. When we're trying to find the C2O4, that means this has to be canceled out. So what are the two experiments that when you divide it by one another, it'll just be equal to 1? The concentration, you divide it, it'll be equal to 1. Anyone see it? Yeah, it would be experiment 1 and 2, where we just have 0.836 and 0.836. Once you divide that, it's just going to cancel out and we'll only be left with C2O4. So now, which one will leave us with a fraction? If I do experiment 1 divided by 2, I can see it's going to be 1/2 for C2O4. If I see 2 divided by 1, 0.404 divided by 0.202 is equal to 2. So I want to do experiment 2 divided by 1. So let's start with our R. So for our R value, 2.08 times 10 to the negative 4 moles per liter times minutes. Divide that by 1, 0.52 times 10 to the negative 4 moles per liter times min. I apologize for my handwriting. Equal to the K value, also the K value on the bottom, the HgCl2, is just 0.0836 m to the first, because we know m is 1, 0.0836 m to the first. And already you'll see that these two are going to cancel out, so we don't even need to really care about that. But then for this, 2 divided by 1, we have 2.08 times 10 to, oh, I'm sorry about that. Not that, that's our rate. We're looking for C204, so 0.404 to the n divided by 0.202 m to the n. So you can already sort of tell that these units will cancel, the k will cancel, these units will also cancel. So I would pause the video and plug this into your calculator, 2.08 times 10 to the negative 4 divided by 0.52 times 10 to the negative 4, and see what you get. And you should get 4 when you do that in the calculator. Hopefully you guys know right now that 0.404 divided by 0.202 is 2. And that would be raised to the nth power. So 2 raised to what power is equal to 4? 2 raised to the second power. 2 squared is equal to 4. Therefore, n has to be equal to 2. And there we go. We found n equal to 2. Let's add that to our rate law, and we're going to have, this is going to be a tight squeeze, squared. There we go. And that is going to be our answer to part A. So I'm going to circle that. Ooh, make sure it's very important that this is a 2. And great, so that was part A. We figured out the rate law according to some data. Hopefully that made sense. At this point, the units are not that important because they're actually going to end up canceling out when you're doing these calculations. But in part B, the units are going to be extremely important as you're going to have to find the units for K. And that is a little confusing for people, especially when they just start. So now let's move on to part B. So we can really look at any experiment we want when we're doing part B. I'm just going to go with experiment 1 because why not, you know? So let's do it. So let's rewrite, or actually let's not rewrite it. So our rate law is very important here. Let's just plug in our values to our rate law. We have everything we need except for K, and K is the rate constant. That's basically K. K is our rate constant. That's what we're trying to find. If we use experiment 1, we have every single value we need except for K. We have the R value. We have the concentration of HgCl. We have the concentration of C2O42-. So with that, we can find K. And if I even wanted to do some isolations here, if I would divide both sides by these two concentrations, I would get the K value is equal to the R value, and I'm dividing those on both sides, HgCl2 concentration times the concentration of C2O42-. Don't forget about that squared, that's very important. So let's plug in our R value for experiment 1. We're going to go with experiment 1. You can really go with any of these experiments and it will all work. So we have 0.52 times 10 to the negative 4. Do not forget units. These units are so important. Moles per liter times min. On the bottom, we're going to have the concentration of HgCl2, 0.0836 moles per liter times concentration of C2O4, 0.202 moles per liter. And again, that's all from right here. I just plugged in the values. And if you're confused, the concentration is always equal. So concentration is always equal to molarity, which is always equal to moles per liter. So that's why I did 0.0836 moles per liter. And you hopefully are noticing that I forgot something that is critical to solving this problem correctly, and that is the squared right here. This is just to the first. If you forget the m and n value that go on the top of your rate law, then it's not going to work. So do not forget that squared after the concentration of C2042 minus. So let's just take a look at our units. So we have moles per liter. If we divide moles per liter by moles per liter, those two are just going to cancel. Actually, you cannot really see this that well. Those two are just going to cancel out. But here we have moles squared per liter. So the units are going to be, since it's like a denominator's denominator, this is going to flip, and we're going to get liters per moles times minutes. This is squared, so this squared distributes. So because of that, you're going to add a squared to liters and a squared to the moles. And that's going to be your units for K. So do not forget that at the very end. So now, all it is a matter of plugging this into your calculator and making sure that you type all the negative exponents in right, making sure that everything is right. And once you plug in, maybe multiply these first and then take that and divide it by that. You guys can pause the video and calculate it. I can just give you what you end up getting when you plug that in. You end up getting 1.52 times 10 squared. And again, the units are liters squared per mole squared times minutes. So some pretty crazy units, but the units are essential when you're solving for K. And again, the K is the rate constant in our rate law. So I'm going to go ahead and circle this as our final answer. And there you go. So in this video, we calculated a specific rate constant, and we formed a rate law, found the m and n values, all based on a set of data that we had provided to us. I hope this video was helpful. Here's the answer to A, and here's the answer to B. Please comment if you have any questions, and I'll respond. Also, subscribe and like the video for me. Thank you so much. Great job.